So solving a quadratic that's given to you in vertex form, or y equals a times quantity x minus h squared plus k, it's solved similarly to if you're solving a quadratic in standard form when b equals 0. And if you're familiar with that form, then you should see the connection quite quickly. So if we take the equation x minus 4 quantity squared plus 12 equals 156, and we start to solve, our goal is going to be to isolate this expression so we can take the square root. So subtracting 12 from both sides gives me x minus 4 quantity squared equals 144. Then I take the square root, so I get x minus 4 equals 12. But I have to remember once again to take the positive or negative square root. That's because two situations can be true to make this equation true. If x minus 4 is equal to positive 12, well then obviously x equals 16, and we can see what happens. This becomes 16 minus 4, which is just 12, squared plus 12. And so what I'd really have is 144 plus 12, or 156. So we can see that if x minus 4 equals positive 12, the answer x equals 16 will work in my original equation. Now, let's say that I took the negative root here. X minus 4 equals a negative 12. Here, when I add 4 to both sides, I'm actually going to be left with x equals negative 8. And how does that work when I put that in here? Well, negative 8 minus 4 gives me a negative 12, and when I square it, it's going to act the same way as this 12 would, right? They're both going to be 144. So I have negative 12 squared plus 12, which is the exact same, 144 plus 12, or 156. So either answer would work in this case, and you have to remember to take the positive and negative square root, and then when you're adding that 4, you're adding it to either the positive root to get one of the answers, or the negative root to get the second answer. If we look at this slightly more complicated example, we'll notice that there's still a big similarity, and the similarity is the only x we see is inside the parentheses and is being squared. So we're going to treat this the same way. What we're going to do is we're going to isolate this parenthesis that's being squared. So I'm going to add 24 to both sides. So I get x plus 2 quantity squared divided by 3 equals 24. Multiplying both sides by 3 will isolate that parentheses. So I get x plus 2 quantity squared equals 72. Now I can take the square root because I have the parentheses by itself. So I get x plus 2 equals positive or negative square root of 72. And then to finish off, I'm just going to subtract 2 from both sides. So it's x equals negative 2 plus or minus radical 72. And the first couple times you see this plus or minus, it looks a little weird. But remember that plus or minus means it's shorthand for two expressions. So it's really negative 2 plus radical 72 is one of the answers for x. And then another answer for x is negative 2 minus radical 72. Both of those are acceptable, and for shorthand we just say plus or minus, and it represents both of those quantities. Also, when I subtracted 2 from both sides, you'll notice that I wrote the 2 in front of the plus or minus, but that doesn't have to be true. So had I written this as x equals plus or minus radical 72 minus 2, that still, once again, would give me two answers. It gives me x equals a positive root 72 minus 2, or x equals a negative square root of 72 minus 2. And as long as we keep the signs in the same place, we can switch the order around. These are going to be the same value. Likewise, negative 2 plus radical 72 is the same thing as radical 72 minus 2. So it doesn't matter if you subtract after or if you subtract before, but what's common in mathematics is to see this before the plus or minus. This answer is not incorrect, it's just a little less common.